Okay, let's formalize what we introduced in the last section. An antiderivative of some function is usually written as capital of that function. Not always, but often. An antiderivative of little f is often written as big F. And big F is an antiderivative if its derivative is little f. That's what we said in the last video. If the derivative of something equals little f. And again, what's in here is the antiderivative of little f. This is the definition of an antiderivative. And we said there are infinitely many of these. We introduced that in the last one because, look, the derivative of this was 2x, the derivative of this was 2x, and the derivative of this was 2x. We found that all three of these satisfied this definition of an antiderivative. There were infinitely many things that were an antiderivative of 2x. They just differed by a constant. Now, a lot of times we talk about the antiderivative, and that's the general antiderivative. We never actually say this word, but that's what's implied. The general antiderivative, we just say the antiderivative of f is written as follows, where c is any constant. The antiderivative is written with an integral sign. The antiderivative of f is capital F plus any constant, and we always write plus c like this. Okay? So this is also, again, this is an indefinite integral, which is just a definite integral without any limits of integration. So there's no a and b here. That would be a definite integral. We'd use the fundamental theorem of calculus. The definite integral of a rate of change is the total change. But otherwise, we can write antiderivatives in this way. And this is going to be a general formula for an antiderivative, which is really convenient. Okay. All right. So there's a couple other things we can do with the fundamental theorem of calculus, but we're going to skip those. They are not too relevant to us. So example 2 and example 3 are kind of restating what we talked about in the last video. There are infinitely many choices you can use here. But again, the important thing is that we choose something whose derivative is 2x. That's the whole point of antiderivatives. The derivative of an antiderivative is just this function. They undo each other. So you could choose x squared. You could write x squared plus 123,000. Pretend that you can see that far. You can do whatever you want. Okay. Choose any antiderivative you want. Let me try to, there we go. Your answer may be a little different than mine. It has to have an x squared component, and it could include a constant. But example 3, again, that's showing the difference between an antiderivative and the antiderivative. This one wants us to write a general formula for it. And the answer is going to be x squared plus c. There's only one answer here. And you can see that our answer in example 2 is just one value of c. C is any constant. And again, technically, c is any real number, but we never actually write that in a calculus class because we have so many c's everywhere. It's generally just understood. So that's the idea of an antiderivative. And then we can write all of the infinitely many antiderivatives with this notation. So let's get a little bit more practice with this. Find the antiderivative of e to the x. And again, to answer this question, we can go off to the side and say, okay, the derivative of what function gives you e to the x? Let's say you're confused. You don't know the answer. Write down the plus c. Any antiderivative. Let me restate this. Any antiderivative ends with plus c. The antiderivative of any function is just some other function plus a constant. So there we go. Even if we know nothing, if we can say that, that's something, right? So what do we take the derivative of to get e to the x? Remember back into chapter 2. And the derivative of e to the x is itself. So that also means the antiderivative is itself, plus any constant. So our answer will be that the antiderivative of e to the x is e to the x plus any constant. Section 3.3, we're going to formalize this process of how to find the antiderivative of any function. Well, not any function. We'll talk about better ways of finding antiderivatives other than we're essentially guessing right now. But this section, we can do some simple ones. And I think that's all I wanted to talk about in this video. So until the next one.